Let's discuss this question next. What does the question say? Using elementary transformation, we are supposed to find the inverse of this. And what kind of a transformation can we use over here? We can use anyone for that matter. Let's use, we have been using alternate, right? So let's use column transformations over here, okay? So we'll use column transformations since we are using alternate, right? Okay, now what does column transformation say? Column transformation says that you'll have to write I as the post multiplier, okay? And this gives me, let this matrix is A. So this is 2, 5, 1, 3, which is equal to A times this identity matrix 1, 0, 0, 1. On the LHS, we need to convert that into an identity matrix by converting A11 first. Then, since we are applying column transformations, we'll have to cover the first row, okay? So let's focus on the first row. First row, this element should be 1. This element should be 1. Now for making this element 1, we'll have to apply column transformation. C1 is replaced by C1 times 1 by 2, okay? This column 1 gets transferred, this becomes 1. This becomes a 1 over here, this 1 becomes a 1 by 2. That's a column transformation. This 5 and 3 remain as it is. This is equal to A times 1 by 2, 0, 0 and 1. Okay. What next? For applying column transformation, next is this element. This element should be equal to 0. After this one, we'll convert this into a 0. So C2, this minus 5 times this. This will convert that particular element A12 into a 0. So C2, this 1 and 1 by 2 remain as it is. 5 minus 5 times 1, which is 0. 3 minus 5 by 2. 3 minus 5 by 2 would be 1 by 2. Okay. This is equal to A times, what do you have on the RHS is? C1 remains as it is, 1 by 2 and 0. 0 minus 5 times this. 0 minus 5 by 2 would be minus 5 by 2. 1 minus 5 times 0 is 1 only. This is what I have, right? Is that okay? Yeah. What else? What else? After you get 1 and 0 over here, we'll convert this into a 1. This into a 1. So let's replace C2 by C2 times 2. Or for that matter, that's the general process that we follow. Can we apply another thing? Can we apply another idea? Yeah. Since this is already a 0, why not convert a 0 over here first? If you can, right? As you can clearly observe, this minus this would be a 0, right? We can do that as well. Is this some mischief? No, there's no mischief, but we can apply after this 1 and this 0, we should convert this into a 1, but we can also convert this into a 0. As you can clearly observe, that subtracting is making life very easy for us. So C1 can be replaced by C1 minus C2, and this will give me 1 minus 0, which is 1, half minus half, which is 0, 0 and half remain as it is. This becomes equal to A times half minus of minus 5 by 2. That will half plus 5 by 2, which is 6 by 2. That becomes a 3. This minus this would become minus 1. This is minus 5 by 2. This is 1 over here. Right? This is 1 over here. What next? This has to be converted into a 1. So we'll have to apply C2 replaced by twice C2. Twice C2. Now what does that give me? This gives me C1 1 0 0 1 is equal to A times 3 minus 1 minus 5 2. This is what you'll be getting. This is what you get, and therefore A inverse is equal to 3 minus 5 minus 1 2. This is A inverse for us. This is the value of A inverse for us. Yes, and that's my answer. Yeah, that's my answer. Anything else which remains? Yeah, we should always verify the answer. We should always verify the inverse in case of inverse. So let's find A inverse check. And this check can be done if it is not asked in the question, it can be done in the rough as well, right? So A inverse is equal to what? This is 2 5 1 3, which is equal times 2 5 1 3 times 3 minus 5 minus 1 2. What else? This is 6 minus 5, which is 1, minus 10 plus 10, which is 0, 3 minus 3, which is 0, minus 5 plus 6, which is 1 over here. And this is okay. This is the identity matrix here. So A inverse is equal to identity, and therefore this A inverse that we have found is correct, right? That is my answer for this question. You can take a look at the complete solution. Yeah, we have used column transformations over here. Maybe in the next question we'll use row transformations, right? This is all for this question.